Okay. Thank you for the invitation, and I would like to thank the organizers of this AIARD industrial event, chair event, for the opportunity to share the work related to trees. It is my honor to give this presentation. My name is Mei Choo. I'm a research fellow in the Institute of Visual Informatics, University Kebangsaan, Malaysia. There are next slide. Okay, these are the contents of my presentation, and I will explain the research that I've done with the help of my students that include data mining, natural language processing to help trees users, and also the trees inspired operators. As you all know that there's a systematic approach to problem solving, which is known as trees. It provides methods that can produce conceptual solutions and even creative solutions. And it has been used by many companies and enterprises to enhance their competitiveness and to be ahead of their product innovation. For those who have been trained in trees, you know that there are classical and modern trees tools which can be grouped into different categories. Some tools are suitable for problem definition, root cause identification, some for solution generation, some for new product or market analysis. However, many trees tools are mainly based on manual approach, and the implementation are very much depending on user knowledge and their expertise. With the advances of computers and connectivity through cloud and Internet of Things that is happening in this fourth industrial revolution era, more and more big data are produced, and big data have three basic characteristics in terms of volume, velocity, and variety. Volume refers to the amount of data. Variety refers to the number of types of data, and velocity refers to the speed of data flow that require high-speed data processing. So big data are data that are large in volume, comes in high speed, and full of different variety. Big data
Mei Choo,
yeah,
excuse me. We can't see your slide moving. You're still on the first slide, so I was wondering if you have pressed the right buttons.
Oh, I have to use that. I was opening my PowerPoint, so I have to use this one now. So sorry, I didn't know that.
Yes, it's okay now.
I see. But I think I already introduced. This is my presentation content. So I've covered data mining, natural language processing, and also the trees inspired operators. So I think I skipped this one. And trees, I think you guys know already. There's some introduction. And where am I now? This is, I think already almost just a little bit, yeah. I just now talk about big data. So to manage and process this huge data, we will need AI to identify the correlations, patterns, trends, and to make sense of data and make decisions. Okay. So next. Okay, the figure in this slide is I obtained from the WIPO, World Intellectual Property Organization. The figure shows that there are many patents being granted from 2006 to 2020, and the patent data are increasing every year. This indicates large volume of new patents, and it is increasing very fast. Patent also has a high variety. For example, there 450 classes of invention and about 150,000 subclasses of invention in the US patent classification. So patent data are considered as big data, and they are a source of problems and also the idea for the solutions for that problem, and it's very useful for trees users. So as put together, trees provide us the methodology to formulate a problem and solution. But if need to dig into how to solve that problem and finding information from different domains, I think nobody is capable of handling the vast knowledge. For example, in this case, all the knowledge in patent database, it will be too much for us to analyze without the help of AI. So we need AI in the form of machine learning, natural language processing, an algorithm to help us to make better and data-driven decisions. As most of you know, many trees tools are given in the form of manual and textual guidelines. So when using trees tools, users need to analyze the problem. Then they map the problem into general problem in trees. The general problem will have some general tree solution generated through the application of trees tools. So, for example, if you want to use trees inventing principle, we will need to use manual in the form of contradiction matrix, and user need to analyze their problem. Then they map their problem into a general problem in trees in the form of contradiction to find the general solutions. So it is common for engineers to struggle to translate general tree solution to specific solutions, as the tree solutions are usually very abstract, general, and require in-depth domain knowledge and expertise. Since one of the sources to look for ideas of the specific solutions is from patents, we propose to explore the natural language processing to do the patent mining to assist engineers in the translation of general tree solutions to specific solutions. There are two main trees tools that were being explored with patent mining, and they are TSE and trees scientific effect. For patent mining and TSE, we have created automatic radar plot for trend determination using natural language processing in patent mining for remanufacturing industry. I believe remanufacturing, right? It is one of the strategies to support circular economy. Remanufacturing is useful in extending product lifespan and reduce pollutant to the environment, but it is very challenging and complicated. Using the operations as keywords, I hope you will show on. Right? Oh yeah, yes. As you can see, the number of patents were very high. Based on the features and description of each trend, we have actually built a collection or a library of words for each trend and use them as a reference to search patents that are similar to the trends. So far, we have managed to try 7 trends from the TSE. And so in this case, based on keywords, remanufacturing cartridge, remove screw, we have found 1,402 for remanufacturing. 1,072 patents for the removed screw, and 202 patents for remanufacturing cartridge. And the program generated product plots to have to give us overview of the trends. Overall, these product plots suggest that the number of patents are highest in the trends of transition to super system, and the lowest number is at the trend of elimination of human involvement. This indicates the patents incorporate external system tools or external process in the patent, and usually the patents are manual approach, still depending on human labor. In the second case study, we had proposed to integrate trees scientific effects and patent mining to assist engineers to solve pipe corrosion problem. In this work, the scientific effects was based on the database from Mr. Andrew Martin. It provides us the basic information to our work, and we also produce a graphical user interface. So the program includes the ability for users to input their concept features. This is the general flow of the program development. So the development of the program was first focused on data extraction from both the tree scientific effects database and also patents from the USPTO. Among them, we have used doc2vec to convert patent document into vector representation, which will be used to find similar words in patents that correspond to certain scientific effects and problems input from the users. And this is a graphical user interface which is developed, and you can see it here. It is loaded for user to input about the corrosion of copper pipelines caused by seawater. And after the user input, the program will compute using the similarity model and retrieve relevant patents to the suggested effects. This slide shows top 5 results of the similarity model after evaluating all the inputs, and the full set of results are kept in a separate output file, which can be analyzed separately if needed. This is a third case study. Now it's slightly different from the earlier on case studies using natural language processing to find idea for solutions. The following case study does not use patent mining, but use trees inventive principles to inspire better intelligent search operators. It is applied for PCB assembly problem. PCB assembly is a process of placing electronic parts or components such as resistors, capacitors on a PCB board, and usually it is a time-consuming process. Thus, this assembly need to be optimized such that the sequence of component placement can minimize the total manufacturing time. PCB assembly problem is considered as a discrete type of problem, and there are 2 common operators being used in the BIS algorithm, and they are point insertion operator and swap operators. These operators are also used by other researchers in genetic algorithm, in solving discrete type optimization problem. And tree's inventive principle were used to inspire better intelligent search operators for BEAST algorithm. And three inventive principles identified from the 40 inventive principles. And not all 40 inventive principles were used because most of the principles are difficult to be translated into programming strategies. And the three inventive principles being used in the trees inspired operators are dynamization, segmentation, and the local quality. So this is a summary of the result of the implementation. We have obtained the best timing of 23.42 seconds. The slide shows the assembly sequence, feeder arrangement, and the component pickup sequence that help to produce the minimum time of 23.42 seconds. And this is a comparison table. The assembly times from different references listed for comparisons. As you can see, the trees inspired operators have provided the most desired timing for this assembly problem. So I think I reached the end of my presentation. This presentation will not be possible without the help of my research associate from University Kebangsaan Malaysia and University of Nottingham, Malaysia. They have provided many inputs and helped develop the TSC program and tree scientific effects program to generate results. Again, I would like to thank the organizers and the audience for giving me the opportunity to speak in this prestigious event. I really appreciate that. With that, I would like to end my presentation. I hope you find it useful. Thank you for your time and attention. Thank you so much.
Thank you. Thank you very much, Mei Choo. We are glad to have you here. Probably very late in Malaysia in the evening.
Yeah, it's 10 o'clock now.
Yeah, and we have time for maybe one question or comment from the audience dedicated to what we have shown so far. Elias?
Thank you for the presentation. I'm not, but my question is in contrast of what was presented up to this point right now. Your work focuses more what we will call more classical methods, more continuous values-based methods, like for example the multi-swarm agent method, or for example some classical methods. How do you see this kind of method fit within trees and the new wave of AI, and how do you see these kind of methods coexist within the current ecosystem of current AI technology?
Okay. Although they are considered as classical trees tools, and I think, in my opinion, it is many people knows about it, understand them, and also very basic. So it's a good starting point to explore and use it, and try to integrate with the AI, and then from the experience later we can actually expand, use our experience that we learn from working with the classical trees tools to produce the better tools later on. I think it's all possible. It's not that I'm saying modern trees tools are not useful, but I think in terms of understanding, I think classical tool is much more established. That's what I think. Yeah.
Okay, thank you very much. So
Thank you.
we thank you, Mei Choo, once more for your
Thank you so
speech.
much.
And I'm also thanking you for connecting us with the Malaysian community of trees, which we know it is very, very dense and very active. So we really hope to intensify the relationship we have with Malaysia, Europe, and Eritrea conference even more, and probably with the president of Eritrea very soon, we will enter into a discussion with Malaysian community of trees to go deeper in our relationship. Thank you very much.
Oh, that's wonderful. Yeah.